So my day job is in ecosystem enabling at Intel, but I'm the marketing working group co-chair at the UCIe consortium. So that's what I'm here to talk about today. So UCIe has been growing up quickly. We're founded with companies that were collaborating to create an open standard for interconnects for chiplets. And it's a cross-section of people from end user like a cloud service provider to foundry to chip design companies and packaging. So cross industry expertise is where we started, and now we have over 130 members, including Keysight. So we've really been growing and collaborating and advancing specification. I'm going to tell you a little bit more about. So we had a 1.0 specification and then a 1.1 specification last year, and we're working on more iterations coming. There are a few key things from where we started that we added in the 1.1 specification. I'm just going to touch on the highlights here. So one is we're looking at a complete stack of what you need to be able to build a chiplet-based solution. And so there's electricals and protocols and packaging and things like that go into it. But we also are looking at what are the usage models. And so automotive is one particular industry segment where we spun up a working group that's just thinking about the things that you need for safety in automotive industry that are cutting across all of the different other work groups within UCIe. So we've got some enhancements that I'll talk about there. We also are providing the layers of the solution stack, so from the physical layer to the die to the protocols, and so I'm gonna tell you a little bit about how you have flexibility there on how you build a solution. And then I'm just gonna quickly touch on some of the things going on the aspect of packaging, and then lastly, the importance of being able to have compliance testing and interoperability to make this open ecosystem take off. So automotive, when we formed the work group, we basically were building off of what was already in the 1.0 specification and saying, what are the things that we could quickly do to enhance UCIe for automotive? And so some of the things that we looked at were really about reliability. And so there were some registers and data that are collected as part of the initialization process for connecting the chiplets together. And by making some enhancements, you can regularly use those to monitor the health of your chiplets and your SoC, and start to think about what you would do if there were any issues. So this is an example of something that we were able to quickly do in the 1.1 specification, and there are a lot of other things that are going on now as we look forward to future versions. So I mentioned also the different layers of the stack. So the physical layer, you could just use the physical layer of UCIe, but we also provide the capability to put on protocols on top. And so written into the initial 1.0 version of the stack is kind of an optimized version of PCIe and CXL. And so that is ready to go if you want to have that kind of plug and play experience, and as you kind of are taking something from a system level and trying to put it on a chip. But there are other protocols. So maybe someone has another standard that they want to implement, or they want to do their own proprietary protocol. So that's supported in UCIe. In addition, there's a multiplexing function so that you could actually leverage pieces of PCIe for establishing a link or doing some manageability things at the same time as you're running other protocols. So that's another enhancement that came out in the 1.1 specification, and we're doing more things like this going forward. So, we also are thinking about optimizations for packaging. So UCIe has support for both standard and advanced packaging, standard organic, however you know it. And so, as we're looking at how do we make things that are going to be multi-vendor, interoperable, and standard, we are thinking about what are the optimizations that we can make for things in the packaging like the ball out. So, these are some examples, and there's a lot of engineering analysis and modeling going into thinking about what are the sweet spots, and again, taking the collective input across perspectives across the industry so that we can do things that'll help people build interoperable chiplets. Okay, and so how are we going to know that things are actually going to interoperate? So you adhere to the specification, but we're building into this compliance capability, and eventually we may have a full compliance program. As an intermediate step, we're working on ways for companies to be able to do interoperability testing. And so, as this evolves over time, there are different ideas that people are working on in the work groups for how you would do this. So an example would be, we may have a golden die, and there's going to be some test capability configuration where you would bring in your particular chiplet, and then we would have the capability to do some compliance testing. So that's something we're working on for the future. Okay, so the usage models, again, cross industries. I mentioned automotive, but obviously there are companies, including Intel, that already are using chiplet-based designs today. The origins of UCIe, leverage some of that technology, and so this is really, what we think is going to open up innovation. So whether you're disaggregating, whether you are innovating, and so you want to focus your energy on your particular IP chiplet, and you want to leverage another chiplet from somebody else in the industry, and have an interoperable open ecosystem that you can build off of, and that's the vision that we are hoping to enable. Again, I mentioned the flexibility in the protocol, so that there's different ways that you can combine things. So here's an example where you may want to be able to use UCIe at the physical layer, and then Amba-Chai is an example of another protocol choice. So that's not built into the specification. The specification enables that, and then there are some additional things that other ecosystems are doing, and you can read about to really go beyond this to chiplet to chiplet, die to die. From the specification, so you can read the specification to get all of the details, but again, we're bringing industry leaders in so that we have best-in-class specifications, and I think the traction that you're seeing as we grow our membership, and as we start to see examples of the IP in the market, and test chips, demos, things like that you can find online, you'll see that these specifications are resonating. And last but not least, so to build this, a full ecosystem, you got to have the complete solution stack, software, manageability, robust standards. We need the ecosystem to build all the tools to help people implement it. We have the manufacturing pieces, so support from the major foundries, and then companies that are going to decide how are they going to put this together, whether it's an in-house solution, maybe something that's co-designed, or something building eventually from an open marketplace of chiplets. And so we think that this is just something that you're probably hearing a lot about here at DAC, and an exciting thing that I can't wait to be part of as it unfolds. So last but not least, if you haven't joined UCIe and you're interested, there are a lot of different ways to get involved. You can be an adopter. You can be a contributor if you want to sign up and actually vote and work on shaping the specifications. There's also a lot of information about UCIe online. There's a webinar from April that Keysight was part of, so you can actually hear a little bit more about their products and their perspective on where the chiplet ecosystem's going, and why they're excited about UCIe as well. So I encourage you to go check that out. Thanks.